This is A3, and this is continuing the decomposition and breaking down problems. This week we're going to look at pattern generalization and abstraction. So what we're going to do is two parts. We're going to identify information that you need to solve a problem, and then we're going to filter out that information that you don't need. And then we're going to try and represent that problem by identifying certain parts such as the variables, the key processes, things that repeat, your inputs and outputs. So very similar to the previous tasks. We've already talked about abstraction a little bit, where we looked at the tube map. We said that the London tube map was an abstraction of the real routes, the simplified routes. And we also looked at how computer languages were abstractions of the layer below. So high-level languages are an abstraction of assembly language, and assembly language is an abstraction of the machine code. So what we're going to do now is look at different problems together and find out what common elements we have. So in this example we have three different vehicles, and they look very, very different, but what we want to concentrate on is not how they look. We want to concentrate on how they function. What elements do they have in common? So they all have four wheels. I know you can't see all the wheels in the photograph, but they all have four wheels, and the wheels are joined together by two axles. So the way in which they steer and roll will be very similar. If you were making a basic mechanical model of this, you might be able to use that for all three vehicles. They all have some type of chassis. So obviously one's metal, one might be wood or canvas, the other one's metal but doesn't encase the whole person. But in terms of its mechanical properties, it might be very similar. It's a mass that will have to move along with the wheels, and it might have a bounding box or an area for, if it was a game, it would have collisions. Physics might act on it in a similar way. And all three have steering mechanisms. So the front axle will turn to rotate the wheels. And again, mechanically, that might be quite similar. The internal parts will be very, very different. But for a simple model, maybe for a simple game, you could probably treat them all identically without going into too much more detail. So don't just look at the physical appearance of an object or problem. Try and think about the functional elements of that problem. Look at it in a bit more detail. So there are two parts to solving a problem. We need to identify the information that's necessary, and we need to filter out information that's not necessary. So when you're identifying your information, you need to know what information you need. You need to know why you need that information. So if you're making a car game and you need to know the mass of the car, you might need that for your physics equations, so that it will behave properly. You might need to know the spring tension in the shock absorbers or something like that. Know the format of the information. So is it a highly detailed decimal number, or is it a whole number? Would that suffice for what you're doing? Or will it be text or Boolean, true or false values? And know how quickly you're going to need that information. Sometimes you can You can gather information as you're going along, and it will fit into your model, and you can just add that later on. Other information might be very critical for developing the project at the initial stages. Once you've collected information, you might need to filter out what you don't need. So maybe you don't need to know the tire pressure. Maybe you don't need to know that it's metal or plastic. Maybe you don't need to know lots of things like that. You don't need to know the colour of the cars. It's not important. And then you might want to justify why you've excluded that information. You might not want the tire pressure because you're not performing any calculations with it. Your model only requires simple mechanics, and it's not that detailed. Once you've done that and you've had a good look at all the parts in the problem, you're going to try and represent it with variables. So variables are used in programming to store information. So they can be numbers, they can be text, they can be Boolean values, and you could use these for calculations. You could use them for code branching to decide different things might happen. Sometimes those variables will be in the form of collected data. Sometimes they might be real-time input from the user. So if you're filling in a form, that form will gather the required data and save it in variables. Constant values are values in your system that you don't change. So if you're making a car game, you might need gravity to calculate some of the forces of the car on the road. The gravity would be a constant force, and so would pi if you want to calculate how far the wheels rotated and how far the car's moved. Those values will not change, and you store them as constants. The programmer will then know that that value is fixed. Some languages won't let you change the value of a constant. It's declared before the program initializes. So once you've got that, the variables and constants, you need to think about the key processes that will happen in that system. That's absolutely fundamental. So if it's this car game, then it might need to calculate, the forces, the force of the car on the road. It might need to know its speed, velocity, direction, and lots of features like that. That might be a fundamental process that happens all the time during that game, whereas other things might not be that critical. Being able to swap the colour of your car, that might only happen in the menu system, and that's it. It doesn't happen in the rest of the game. Repeated processes that occur multiple times. So like I've just mentioned, every frame of the game would need to be redrawn. So that's a process that occurs multiple times, and the physics calculations will need to be recalculated. Inputs, so that's the values you're entering into the system. That could be a joypad controlling the car, or it could equally be an online form or an application. Might be an application to calculate one value and turn it into another value, say kilometers to miles. So you would need validation with that. You couldn't enter a value of 20 million miles perhaps. It might be out of range of that application. Maybe it's an application to calculate the size of your carpet. 20 million miles wouldn't make sense. So the numbers have to be constrained within your application. What's acceptable values? If you were calculating the area of something, you wouldn't allow a negative input, you wouldn't allow someone to enter -5 when you're calculating area, because a negative area wouldn't make sense. So the validation will check the values before any calculations are done with that information. And the last part is the outputs. So the outputs is the part that's going to be presented to the user. So if it's a game, it might be the rendering of that current frame in the game. And if it's an application, it might present some information, numerical information, or text-based information. It might actually print something out, it might show a graph, but they're all outputs. So when you're going to write a program, you need to think very carefully about what you need and what you don't need. So a good example of this is when you're designing a database. If you don't take into account what you need at the very beginning, it can be very difficult to add things later on, because the database may not function as expected. So I'm just going to have a look at an example of a health club, and you might have to make an application to handle the bookings and allow members to log in and book different activities at the health club. They might have cards with barcodes and be able to log in with the barcode when they get to the health centre. And the system should make reports and extract data and all that type of thing. What sort of things would we need to do that? So thinking about the data itself, you would probably need some type of database, and you might need some tables in that database to store the members and what they're going to do, and the payments and the bookings. All the things that would happen would need to be in there. They're supposed to be on separate pages, but never mind. So you'd also need some forms. So forms are a way for users to enter data into the database without having to see the back end of it. So you might need a menu that allows people to select where they're going in the data structure. You might want a form to add and change members. You might want a form to make bookings, a form that allows you to print reports out. And the reports you make, they might show the weekly schedule, they might show members, their activity, or payments or receipts. So this is just a quick example of how you can think about what would happen in the system, what type of data do you need. All these things need to be accounted for before you start making your application. So in class we had a look at designing a running app. So we thought about what data might you need for this application, what would it do. So we thought about does it have a map, does it have a stopwatch, a distance, pace, does it have time splits, does it have calories or BPM counter or GPS. There's lots of features you could possibly include, and your development time might not allow you to do that. You might only have a few weeks, and you've got to filter out some of that and just pick the essentials that you need. You don't want to fill it with thousands of features. You need it to be a clear, easy to use product. So I'm going to set you a task. What I'd like you to do is design a mobile phone app that helps the children to learn their times tables up to 12. So it's a very simple application. It just helps children learn their times tables up to 12. Using Figma, I want you to make a mock-up of what this app might look like. So you might have a menu, you might have different modes in the app, or you might have, without giving you, I don't want to give you any more clues, just think about what it might include and how many pages you need and what would be on each page. I want you to make a list of the features before you do the design work. I want you to think about everything that will be in this application before you make a design. And then I also want you to list any variables you need, what processes will happen in this application, is anything repeated in this application, and does the user input anything, and are there any outputs? I want you to break it all down. It's a small application, but I want you to try and think of as much as you can and design it as well as you can. And then I'll take a good look at it and give you some feedback. So hope that goes well, and I'll see you soon.